Hey everyone, today we're going to be simplifying rational expressions. A rational expression is an expression that is a polynomial divided by a polynomial. To simplify rational expressions, we have to factor first and then make sure there are no common factors in the numerator or in the denominator. So let's look at AC divided by BC. C is our common factor, so we would eliminate that common factor, and so we'd eliminate those C's and just be left with A over B. Remember from simplifying expressions before, when we divide, we subtract those exponents. So x to the 6th power divided by x to the 1st. Remember there's an understood 1 right there. We would say 6 minus 1, which is 5, and then 5 minus 1 for the y's, which would be 4. Okay, we're going to do the same thing for b. We're going to first eliminate our common factor. And 12 and 3 are divisible by each other, so 12 divided by 3 is 4, 3 divided by 3 is 1. Subtract those exponents. X to the 5th will be x cubed, and then y squared divided by y to the 5th. Remember, it's bigger in the denominator, so y to the 3rd power is going to stay in that denominator. For c, the first thing we need to do is distribute that 2. Remember, if we raise a power to a power, we multiply. So x, 2 times 2 is 4, y, 2 times 2 is 4, over, now we're going to go to the denominator. That exponent still goes to everything in the denominator as well. So x to the 6th power, and then y squared, excuse me. Now we subtract as normal. 4 minus 6 is 2. Remember, it stays in the denominator because 6 is bigger. 4 minus 2 is 2, and it's going to stay in the numerator because 4 is bigger in the numerator. All right, let's look at some more examples. So if we can, sometimes we don't have a binomials, and we have binomials or trinomials, so we need a factor first. So for number 2, we're going to factor out an x first, because that's my greatest common factor. If I take an x from x squared, I'm left with x. If I divide 5x by x, I'm left with 5 over x squared. Okay, remember we have 1x in the numerator, we have 2 in the denominator, so I'm going to be left with x plus 5 in the numerator and just an x in that denominator. All right, for b, we need a factor first. So I need two numbers that multiply to give me negative 12, but add to give me negative 4, negative 6 plus 2, and then factor that difference of two squares. Remember, this is our special case. Take the square root of x squared, take the square root of 4. I need a positive term and a negative term. Now we're going to eliminate what is alike. They have to be identical, so that x plus 2 is the same in the numerator and the denominator. So I'm left with x minus 6 divided by x minus 2. For c, I'm going to do the exact same thing. I'm going to factor first. So x, I need two numbers that multiply to give me negative 6, but add to give me negative 5. So negative 6 plus 1, negative 6 times 1 is negative 6, negative 6 plus 1 is negative 5. And then use the difference of squares again. The square root of x squared is x, the square root of 1 is 1. I have a positive term and a negative term. I'm going to eliminate what is the same, and so then I'm left with x minus 6 over x minus 1. Now, sometimes we just have to multiply. So we're going to multiply our coefficients first. So we will multiply those first. So 5 times 6 is 30. And then when we multiply bases that are the same, we add those exponents. So x squared times x cubed would be x to the 5th. Y to the 1st, there's an understood 1, to x squared, y squared would be y to the cubed. 2 times 10 is 20. There's nothing to combine x with. X cubed, again, there's an understood 1, so y to the 4th. Now we're going to simplify. Easiest thing to do is to get rid of those zeros first. So 3 over 2. X to the 5th divided by x to the 1st will be x to the 4th. 5 minus 1 is 4. And then y to the 3rd divided by y to the 4th. It's bigger in the denominator, so I just have y. Okay, b is going to work the same way. We're going to multiply first. 6 times 10 is 60. x squared times x cubed is x to the 5th. Y cubed times y to the 4th is y to the 7th. 2 times 18 is 36. There's nothing to combine x squared with. And then y squared times y squared is y to the 4th. Now we would simplify. 60 and 36 both have a 12 as a common factor. The 60 divided by 12 is 5. 36 divided by 12 is 3. X to the 5th minus x, or divided by x to the 12th, x to the 2nd. 5 minus 2 is 3. And then y, 7 minus 4 is 3. So this is kind of a review of what we've already done. So now let's look at some stuff that's a little bit harder for us. Okay, so the first thing we're going to do is multiply the expressions. Well, first we're going to simplify and then we're going to multiply. So I'm going to factor out all my greatest common factors. Also, I'm going to rewrite this negative 4x squared first because it'll be easier for me to factor. So reorder at 4x squared plus 4x. All I did was bring the negative to the front. And again, this 4x was originally positive. Times x squared plus x minus 6. And then x squared plus 2x minus 3. And then over 4x. So in the first one, I'm going to factor out a negative 4x because that's my GCF. Since it's negative, I'm going to take out that negative. And I'm left with x. I take a negative 4x from positive 4x minus 1. Okay, again, I'm going to factor my denominator. So I'm going to have x, two numbers that multiply to give me negative 3, add to give me positive 2, positive 3, negative 1. And then again, I need to factor that numerator. So x, and then negative, oops, sorry guys, this would be, we need negative or positive 3 and negative 2. Hold on one second, my computer's a lot. Okay. All right, and then there's nothing we can do with that denominator, so we just keep it. So now I'm going to start eliminating what's the same. I have an x, 4x, numerator, denominator, but I'm keeping that negative because it can't cancel yet. Well, actually, it can't cancel at all. And then I see an x minus 1 in the numerator. I see an x minus 1 in the denominator. I see an x plus 3 in the numerator and x plus 3 in the denominator. And then I'm left with just that negative x minus 2, and so negative x plus 2 when I distribute it in. So a little bit of work, but it's okay. All right, again, I'm going to move this to the front so that we don't have to deal with that negative. So negative 27x cubed plus 3x over 3x squared minus 2x minus 1 times 3x squared minus 4x plus 1 over 3x. Okay, I'm going to factor out a negative 3x, and I'm left with 9x squared minus 1 over, here we're going to have to do a little bit of moving, so we're going to move that 3, and I'm going to do it at the bottom. So we move the 3 so I can do slip, slide, and divide. So I need two numbers that multiply to give me negative 3, add to give me negative 2, so negative 3 and positive 1. Now remember, we moved the 3 over here, so now we have to divide by 3 in the bottom. If it's a whole number, it stays. If it's a fraction, it gets pulled back to the front. So 3x plus 1. So x minus 1, and then 3x plus 1. I'm going to have to do that same thing over here, so I'm going to go underneath this first example. So x squared minus 4x plus 3, factor x plus 3, x minus 3, excuse me. X minus 3, x minus 1. Again, we move that 3 to the back, so now we have to divide by 3. So I'm left with x minus 1 This is a fraction, it gets pulled forward, 3x minus 1. So times x minus 1, 3x minus 1. Still over 3x. Again, I'm going to cancel, oops, no, I have to do one more factoring. Notice 9x squared minus 1 is the difference of two squares, so we got to do this one more time. So 3x minus 1, 3x plus 1 over x minus 1 and then 3x plus 1 times x minus 1 and then 3x minus 1. Sorry, it ran off the page. I'm running out of room a little bit, guys. All right, and then 3x. Now I can start eliminating. I have 3x in the numerator and a 3x in the denominator. X minus 1, x minus 1. This is a 3x minus 1, so there's nothing I can do with it because this is a 3x plus 1. But I do have a 3x plus 1 in the numerator and the denominator. So I'm left with negative, and then 3x minus 1 times 3x minus 1. And we can just leave our answer like that if we want to. Now let's look at our other examples. These are a little bit more difficult because we're going to have to remember those sum and difference of cube rules. So the first thing I'm going to do is remember those rules. Remember, we have a plus b. So a cubed minus b cubed is, so let's start over with that. So we have a cubed minus b cubed would give me a minus b times a squared plus ab plus b squared. So x plus 3. Then we have the cube roots. That's going to give me 2x minus 1, because the cube root of 8 is 2, the cube root of x is 1, times 4x squared plus, because it's always positive, a times b, so 2x times 1 is just 2x, and then plus 1. Times, and again, we're just going to write this 4x squared plus 2x plus 1 over 1. Now, notice how these two are exactly the same, 4x squared plus 2x plus 1, and then 4x squared plus 2x plus 1. We can eliminate those. We don't have to do anything else. So I'm just left with x plus 3 over 2x minus 1. But you got to remember those rules first. So the same thing's going to happen for d. We're going to have x plus 2 times 9x squared minus 6x plus 4. Got to remember those different. This one will be the sum formula. Remember, my sum formula says a cubed plus b cubed. So I have a plus b times a squared plus ab plus b squared. And that should be a subtraction. So first sign is the same, second sign is mine, opposite, and then last sign is always positive. So we're going to put that over 1. The cube root of 27 is 3x plus 2, and then times, that one over a little bit. So 3 squared is 9x squared. 3x times 2 would be negative 6x plus 4. Again, this would be over 1. So as you can see, I have the same thing in the numerator and in the denominator. They can cancel. And I'm just left with x plus 2 over 3x plus 2. And that's it, guys. Thank you. Y'all, if you have any more questions, let me know.